All right, so I'm going to go over Module 11.2 review. It says simplify. Your answer should contain only positive exponents with no fractional exponents in the denominator. So on number 1, I have 3 times n to the 1/2. Oh, sorry, that's n squared there. So because n squared and n to the 1/2 have the same base, I'm going to use my exponent properties, which tell me that I can add those exponents, and I'll get n to the power of 2 plus 1/2. And in order to add 2 plus 1/2, I need to get common denominators. So I'm going to multiply top and bottom by 2 and get 4 over 2 plus 1/2. 4 plus 1 equals 5. So I'm going to have 3n, and we just found that this equals 5 over 2. So because my answer is simplified with only 1n and a power of 5/2, I have only positive exponents and I have no fractional exponents in the denominator. So I'm done. For number 2, I have this one and this one that have the same base. So I'm going to rewrite this as 4 times n, and then what do we do with our exponents like we did on number 1? We add our exponents. So negative 4/3 plus 5/3, and I get 4 times n to the power of negative 4 plus 5 is 1/3. And there we go. So for number 3, I'm going to simplify the tops first. I have 3 to some power times 3 to some power, so I know that I can add those exponents on top. So I'm going to get 3 to the power of 3/2 plus 1/2. And I didn't do anything with the bottom. So on top, if I simplify 3/2 plus 1/2, I get 3, let's see, that's 3 plus 1 is 4, so 4/2, and 3 to the negative 2. Now we can reduce this fraction or simplify this. We have 4 over 2, well that's just 2. So if I have 3 squared over 3 to the negative 2, I can either subtract my exponents or I can move my negative exponent to the top, and I would have 3 squared times, and then I just moved the 3 squared to the top, which is 3 to the 4th. If I subtracted the exponents here, I would have a 2 minus a negative 2, which would still give me 4, and that's 3 to the power of 4. So either way, I would have got the same answer. For number 4, I'm going to think about this a little bit differently, because it's not like I have a squared times a to the power of 5/3, right? If it was that, I would add my exponents. But I no longer have that property. Instead, we have to think about this as a squared to the power of 5/3. So what do I do with these two numbers? Some of you guys have trouble remembering the properties, so I think about it in terms of just integers instead of looking at them as rational exponents. Let's see. If I had x squared to the power of 3, that would be x to the power of 6. Or another way to think about that is x squared times x squared times x squared, which is x to the power of 6. So it means I have to multiply these exponents, which is the same thing I'm going to do with these ones here. So a to the power of 2 times 5 over 3. And a common mistake is you'll multiply that 2 to both of those, top and bottom. But remember, this is a 2 to the power of 1 times 5 over 3. So 2 can just be written as 2 over 1. And so I multiply straight across, and I get a to the power of 10 over 3. For numbers 5 and 6, let's see. I have v to the power of 7/4 over v to the 1/2. What can I do with those exponents? Again, I try to think about this in simpler terms, and I say, what would I do if it was like this? Well, that would be x times x on top and x times x on bottom. These would cancel out, and I would get x to the power of 1, or reduce out and get x to the power of 1. which means I subtract my exponents. So I'm going to do the same thing here. Now notice there's a 4 coefficient. So as far as the 4 goes, that's going to stay down there. And then here I'm going to subtract my exponents, and I get v to the 7/4 minus 1/2. To subtract fractions, you need common denominators. So I have, on top I have v to the power of 7/4 minus 2/4 all over 4. 7/4 minus 2/4 is 5/4. And I have a 4 on bottom. For number 6, same type of thing. I have an exponent on top and an exponent on bottom. What am I going to do with those exponents? As long as the bases are the same, I can subtract them. So the 3 and the 4, I can't reduce those. Nothing comes out of both of them, so I leave them. And on top I have m to the power of 2 minus -3/2. I subtract these exponents. I'm going to write 2 as 2 over 1 so I don't forget that I need to get common denominators. And then a negative times a negative is a positive. So if I get common denominators, I multiply top and bottom by 2. And I have 4 over 2. 4 over 2 plus 3 over 2, that's 7 over 2. So my answer here is going to be 3 times m to the power of 7 over 2 all over 4. Number 7, my exponent on my b, when we don't see one, we know it's to the first power. So if I'm going to look at b to the first power and b to the -3/2, I subtract those exponents, and I get b to the power of 1 minus -3/2. And the 3 stays on the bottom because it didn't have a negative exponent, it didn't have anything to reduce with, so it just stays there. Now, getting common denominators, I have to multiply top and bottom by 2. Don't forget this is a plus because a negative times a negative is a positive. So 2 plus 3 is 5. So b to the power of 5/2 over 3. 2 times 1 was 2, plus 3 gave me 5, and my common denominator was 2. For number 8, I have my p's with the same bases. I also have my 4's with the same bases, right? So 4 divided by 4 reduces to 1. Then for my p's, I know I can subtract the exponents. So I have p to the 1/2 minus 3/2. And I have common denominators already, so that's good. There was nothing on bottom, so we could say a 1 on bottom if we wanted. 1/2 minus 3/2 is going to give me p -2 over 2. And that's just p to the -1. Can I leave it as a negative exponent? No. So I have to bring that to the bottom, and I get p to the first power, or just 1 over p. Okay. Moving on to the back. I have x squared and x to the 1/3. So those have the same base, so I can subtract my exponents. X squared minus the 1/3. I have to get common denominators. Multiply top and bottom by 3. So what is that? X to the power of 6 over 3 minus 1/3. 6 minus 1 is 5. So I'm going to get x to the power of 5 over 3. Looking at number 10, I see v squared to the power of 1/3. Well, we went over this in an earlier example where we're going to multiply these exponents. So I'm going to get 2 over 1 times 1 over 3 is v to the power of 2 over 3. On bottom, I have v to the -5 over 4. Now I can either subtract these exponents, or I can bring this one to the top, and I'm going to end up adding their exponents. So I would have v to the 2/3 times v to the 5/4. And since I have same base, I add their exponents. So if I'm adding these exponents, I know I need to get common denominators. Between 3 and 4, I'd multiply this one by 3 and this one by 4 to get a common denominator of 12. And 4 times 2 is 8, so 8 plus 5 times 3 is 15. 15 plus 8 is 23. 23 over 12 does not reduce, so I'm going to go ahead and leave my answer as v to the power of 23 over 12. Numbers 11, 12, 13, 14, even 15 and 16. So I always think of two things. One, if they have the same index, using my root properties, I can write them under the same root. Okay, if they don't have the same root, then I need to write it in rational exponents with the same bases. So I think about the insides. I think about 2 and I think about 4 and I think about 8. And I think which number can they be written to the same base as. So I know 4 is, sorry about that, let me erase that. There you go. I know 4 is 2 squared. And I know that 8, my inside here, is 2 to the third power. So now if I rewrote these as rational exponents, remember your denominator is your index here, so that's the 4. And my power here is my numerator. And if I rewrote this one, I would have 2, where my index is my denominator, and my power is my numerator. So I have same base. Doing what we did on the previous examples, we would subtract those exponents. Now before I subtract them, I have 2 to the 1/2, right? 2 over 4 reduces to 1/2, and 3 over 6 reduces to 1/2. So if I do subtract these exponents, 1/2 minus 1/2 is just 0. Now if you remember, anything to the power of 0 is 1. Or another way to think about it is 2 to the 1/2 divided by 2 to the 1/2 is 1. So again, if they have same index, then I can write it all under 1. And the benefits of writing it all under 1 is, well, this is 5, this is 5 times 25, and this is 5 times 5. So if I write them all under 1, and I'm looking for a group of 4, hey, under 1 radical, right, I have a group of 4. I have my fourth root here is 5. Okay, number 13, are they all the same root? Well, I have a 3 here, I have a 2 here, and I don't even have a radical on the bottom. So no, I have to think about writing these as rational exponents then. So x squared, y cubed, all to the power of, if I'm writing this as an exponent, it's going to be a 1/3, times x cubed to the power of, remember this is a 2 here, so that's a 1/2, and then on bottom I have x squared. So if I distribute this exponent here, I'm going to get x to the power of 2/3 times y to the power of 3 divided by 3 is 1. Here, if I multiply them, I would get x to the power of 3/2 all over, and again, x squared. I haven't done anything with the denominator here. So my exponents, I have, or my bases are x here, so can I add those exponents? Yeah, that's going to give me x to the 2/3 plus 3/2. Y I haven't done anything with, so y to the first. And that x squared on bottom I still haven't done anything with. So let's see what we would get right here. Common denominators, I multiply top and bottom by 2. I multiply top and bottom by 3. So 4 plus 9. 4 plus 9 gives me 13 over my denominator, which was 6, times y all over x squared. Now, when you have same base on top and same base on bottom, remember you can subtract those exponents. So I'm going to show my work up here, and I'll change color so you can see it. So if I subtract these exponents,